Ibuypower, more like Ibuyproblems, because this gaming PC just came into my shop with some major issues that need to be addressed. Because it's been randomly shutting off on our customer, and after running a couple tests, checking temperatures, it's instantly hitting 100 degrees Celsius when it's put under a CPU and GPU load, and temperatures just continue to climb until it shuts off because it can't thermal throttle enough. And this is a result of, I believe, 3 things that need to be addressed, and that's what we're going to take care of here today. First up, the main thing I think is causing a lot of the issues is that because there's only 3 intake fans, there's no air getting in because look at that dust filter. That thing is absolutely nasty. So we're going to go ahead and clean the system with getting all that dust out and any kind of debris. That should allow for better temperatures just because we'll get better airflow through that radiator that's going to be cooling this entire system. Then we're also going to address, you guys can see, the coolant level has dropped quite a bit. It's never a good sign, and I think we're going to go ahead and do a full reflush of the entire system, get any kind of gunk or particulates that are inside of the loop, get those out, and then as we're already going to be taking this system apart, let's go ahead and repaste the CPU and GPU, and we should be able to drop temperatures by a considerable margin. So the first step in this process is really just to go ahead and get the system cleaned up. Let's get all the dust out before we take everything apart. It'll make my shop a lot cleaner. So let's take it out back and get it blown out. All right, so I got the system out back. We're gonna go ahead and blow it out. We're gonna try out this new Yuki air blower. It's a new one I'm testing out. Normally I use my data vac, but it's kind of a nice portable form factor. So let's go ahead and test it out and get the system blown out. We're gonna start, I think, on the back with that dust filter, because yeah, that's probably the worst part of this entire machine. Look at that thing right there. So let's go ahead and take it and get all that dust out. And that looks a lot better right there. That is a lot cleaner. Cool. All right, let's move on to the rest of the system. So the next thing is the radiator. I'm gonna hold the fans on the other side. And we're gonna get as much of this dust out as we can. Works pretty good. Now we're gonna come around front and get the rest of this dust out. Honestly, this thing is not cutting it. Let me grab my data vac. We'll get some better airflow. All right, so I got the data vac, so we're gonna go ahead and use this. This should definitely be able to move all that air that we need to. So I'm gonna start with the back side, hold those fans in place. Working pretty well. All right, we got that dust out. Now, let's go ahead and flush this system. All right, so the system's cleaned up. The next step here is to actually drain the loop. To do this, what we're gonna need to do is take off this front acrylic piece. This is just like a plastic bezel. And then once that comes off, we should have a drain port where we can go and empty the loop. So I think, as far as what I saw online, there are a couple little catches right here when it indents. You can actually push them in, so there's 4 of them. And as you kind of work your way up, we should be able to pop the panel right off. It's a pretty basic design. It's pretty common with a lot of cases. They're just like little catches. So we'll go ahead and push these in. 3, 4, 5. And on this side, release the top. And just like that, that front panel comes right off. All right, so now that we got the front panel off, now we basically need to drain this loop. To do that, there are 2 screws at the bottom and top. They release the pressure and basically release the fluid, allow us to drain the loop. But in order to do that, I grabbed some tubing with a really thin barb fitting because the sizing and the spacing here isn't gonna work with any normal fitting. So I needed to make sure something was super thin. That's why I picked this one up. I'm gonna run this tubing down to a gallon water container just to go ahead and capture all the fluid. And then I also have a bucket on the floor that should also help with capturing any extra. So let's go ahead and dive right into it and see what we can do. So what we're gonna need to do here is we got a screwdriver. All right, so this should allow me to release the bottom cap. And as soon as I do that, I need to basically screw this guy in as fast as possible. Hopefully we can limit how much spillage there is. So we're gonna pull that, and then we're gonna make sure that we have this tubing go into the bucket and screw that in like so. I don't think they use normal G1/4 threading, actually. You know what? Let's see. I really don't think they did. But we can probably hold it here, minimize the amount of leakage, and I just don't get why. Yeah, they didn't use G1/4 threading. What are they doing? Okay, come on, Ibuypower. All right, well, we got a bunch of the liquid out, but we're gonna have to probably just use a bucket here, I think, just to capture it, because this is just gonna end up being a mess. All right, so backup plan. What we're gonna do is we're gonna pull this system forward more. I'm gonna pull my bucket underneath, and we're just gonna let it drain straight down. I think that's probably the best way to do it with this. Unfortunately, with how they did it, this is really the best option we have, because they didn't use standard threading. I mean, of course they didn't. I mean, this is the Ibuyproblems story of my life working as a computer technician. So, yeah, they didn't use G1/4. That's very interesting. So, we'll let that drain slowly. We'll go ahead and give it a little bit of a speed boost in just a second. To do that, we can basically undo this valve at the top. This will add some pressure in and should speed that process up. So I think it may be G1/4, but it's like it's set in. I'll make sure I get some B-roll of that. But yeah, so, and look at that, fluid is absolutely nasty. Let me make sure I get a screwdriver. Then there's also this little guy right here, which is a another screw. I'm gonna need something a little stronger. This should let us relieve the pressure from the tubes. Should bring more fluid out. If I pull that out, and there we go. We got the rest of it coming out. Draining the entire loop. Yeah, that was definitely a pain. It really shouldn't have been that hard. Pretty much any custom loop, if you have it set up right, it should be really easy to drain. And tilt it, get the remaining fluid out. But yeah, this fluid is nasty. No wonder it's getting clogged. I can actually see some particulates built up at the bottom. So yeah, we're gonna definitely need to flush this system pretty well. But yeah, it's just a pain that we can't use you know, any kind of drain valve. So let's go ahead, let's leave this bucket down below. Let me grab some paper towels, wipe up all the fluid that kind of got stuck. Let me see how much fluid we got stuck in the tubes. Pretty good. We just need to make sure that we get some out of the GPU loop. So let's go ahead and take this bucket again. We're going to give this system a nice little tilt. So I'm going to take the air blower. What we're going to do is actually blow this into that pressure valve. That moved a lot of the liquid that was sitting in these tubes on the side. But yeah, this fluid is nasty. Let me get some pictures for you guys. That should be pretty much everything we need out. We're just going to need to probably wipe everything up that comes out when we take the tubes out, but it shouldn't be too bad now. But yeah, here is that liquid I was talking about. Look at that green color in here. Yeah, that's supposed to be clear coolant. That's not good. All right, so now that we got all the fluid out, I went ahead and put some paper towels down just so we can go ahead and pull all these tubes out, because we need to get to that CPU block and that GPU block to repaste both of those, which should help us drop those temperatures, and then we can go ahead and refill, reflush, do everything that we need to do there. These happen to be shark bite fittings, which are a different style than the traditional fittings you'll see in most custom builds. They do this because it saves a lot on cost. These are a lot cheaper to do, and it saves a lot of time. So what you have to do with these fittings is you push down on like the upper ring, and then the tubing should just pull right out, just like that. We can do that with the next one. Go ahead and just make sure we get any of the fluid that's poking out. So you push down on the actual shark bite fitting and it should come out. Then what I'll do is on the GPU, we'll do the same thing. So push down and then these tubes should come out. Yep, there's one. Push up and then pull down. There's two. We can kind of leave the tubes right here as we shouldn't have to move them all the way out. I think we can get away with it just like this. So now let's go ahead and pull that CPU block out. Again, we're going to need to be very careful with any leakage here. Let me grab a screwdriver. All right. We can pull that block off. And the thermal paste, it's in decent shape, but it looks like it's almost all on the outside. There's almost none in the center, which would definitely cause some high temperatures. But yeah, so we're going to repaste that, and then we'll go ahead and flush the system out, get any extra stuff out. So we'll take clean paper towel, put some isopropyl alcohol on it, and then we'll go ahead and just clean off this thermal paste, which isn't in the worst shape I've seen. They did a decent job, but yeah, I mean, anytime you're about 4 years in like this system, it's probably a good time for a repasting anyways. But also need to do the fluid change, so we might as well go ahead and take care of that. So we're going to go ahead and just wipe off all the extra thermal paste off that. I believe this is a 10900KF CPU. Yeah, so we got the thermal paste off. Now we can go ahead and repaste that CPU, put this back, and that top part of the loop will be secure, and we can just work on that GPU next. So we're going to go ahead and add some new thermal paste onto the CPU. Now that it's on here like this, we can do a couple things. So we're going to go ahead and grab that top right corner. That's the one I usually like to start with. It's the easiest one to get the screw in. And there's one. Now we'll move over to the bottom left as we'll just kind of go in that diagonal pattern to eliminate too much pressure. And just like that, we have a repasted CPU. And all we got to do is put these tubes back, and we should be pretty good. So let me go ahead and show you what I mean by the shark bite fittings. This is probably the easiest way to explain it. There's a bunch of teeth that kind of go around, and they lock into place until you pull them up in a certain direction. So this is more of like a plumbing thing than a liquid cooling thing, and it was kind of brought over from like the plumbing industry, which is nice. They're really easy to work with, and it looks like it's actually something that's going to probably come more likely to consumers pretty soon. When I was at Computex, Fantex was showing off some concepts of their like do-it-yourself kits, and all of them had shark bite fittings, interesting enough. So putting them back in is pretty simple. Basically, you just push them into place, and they kind of lock in. Same thing with the bottom one. Just kind of push them into place. If you pull that collar up, they're kind of locked into place, and they're not going to go anywhere. And they're actually really secure because now you can't just wiggle it out, which is nice. Make sure all these tubes are nice and secure. Not going to have any problems for when we refill it. Now, let's take a look at this GPU and see what we can do with that. So we're going to need to pull the GPU out. So let's go ahead and start pulling power. Okay, there we go. Yeah, so we got pull power there. Then we can undo this release mechanism on the left. We don't have a ton of room with these tubes here. I just don't really want to have to remove them all. We're trying to make it as simple as possible. Plus there's a little bit of liquid sitting here. So what we can do is if we get the screws out for the GPU, we can pull the GPU right out. Yeah, so it does have a pretty cool little water block on it. It looks like it's an MSI card. But yeah, we're going to need to take this apart and get it cleaned up. Make sure we can drop those temps. All right, now to go ahead and service the actual GPU, we're going to go ahead and get this all screwed apart. We basically have to take every screw out that we see here. That will drop the card off and make it pretty easy for us. So we're going to go ahead and use our electric one. Go slow. There's 1, 2, 3. I'm actually going to hold off on doing those ones. I'm going to get the center first. So the center, go in a diagonal pattern just to keep it from hitting where it's not supposed to. And that should be the last one right there. Now, we should be able to separate the card from the actual GPU block. A little bit of liquid still leaking out. And let's see if we can separate it. Just like that. Pull that off. Thermal paste is in decent shape. Thermal pads are definitely good. But the thermal paste, yeah, I mean, it's done okay. It's not doing amazing or anything. I mean, on the card side, not too bad. But we're going to repaste it, put some fresh Arctic MX6 on there, and hopefully that will drop some temps. All right, same thing. Remove thermal paste, isopropyl alcohol. Just go ahead and wipe all that off. A little bit of isopropyl alcohol. And we'll wipe that dye off, making sure that we get as much of that old thermal paste off, that kind of goopy stuff cleaned up. Hardest part is always getting around those edges. Really, it's not that the end of the world there. Really, you just want that dye to be repasted. That's the part that is the most vital, and it's going to be the hottest part there. You can see we got our dye nice and clean. We'll take some Arctic MX6 thermal paste, and we're gonna go ahead and put that onto this dye right here. So we're gonna go ahead and just do a diagonal pattern. You can definitely put a little extra than normal. Just make sure we get really good coverage of that entire dye. That might even be almost too much, but really for these GPU dyes, they're so large, you just wanna make sure they're entirely covered. And usually if you do that, temperatures are gonna be in pretty good shape. So now, what we're going to do is take our GPU block, make sure that that wire is nice and out of the way, line everything up, and we should be able to come straight down onto the die, just like that. Flip everything over, make sure we are lined up. We are, and we can see all the holes should be lined up just how we had them before. And as we had the card this way, we'll bring it back this way just to make it easier. Keep track of all the screws I took out. And we'll start with getting those internal die screws just to hold everything in place, make sure it's nice and secure. Go nice and slow, just pull them in. We'll retighten everything in just a second, but I just want to get the card being held down secure. There we go. All right, shouldn't move now. Now we can go ahead and work our way around and get all those screws into place, get everything tightened to how it needs to be. And I'm just going to go real loose here, and I'll probably hand tighten the outside. Now taking a normal screwdriver, just go through and just give it a little tighten to everything. Make sure everything is nice and tight. It's not going to move. And I don't want to over tighten with the electric driver, just to get everything started with that one. It usually works pretty good. Perfect. All right, that card is now repasted and ready to be put back in the system. All right, so now that we got the card and everything, we can go ahead, push that cable through the bottom, and then just slide our card just around these tubes to get it into place. So we'll lock it down, give it a nice little push. There we go. And the thing is, the tubes are just in perfect place. So now we just take our screwdriver, grab my bit again, and we got 2 screws to hold down the actual GPU. Now it's a matter of really just snapping these tubes back into place, which is super easy because they're shark brake fittings, which is, yeah, just like that. They're both locked in. Pull the collars down, make sure they're secure. There we go, they're not going anywhere. And then really it's just about power. So we can plug in that 6-pin and then that 8-pin. Boom. Card's now installed. And then now, before we go ahead and refill it and flush the loop with some fresh liquid, we're going to go ahead and cover all the vital components. Even though I'm going to run the system not connected to like live power, it's still a good idea just to have some of these more important components covered. Make sure there's no leaks. Nothing's going to get on that GPU, which is really the most important thing, or get down onto that motherboard, which is the thing that we're always worried about. So that's good. These tubes up here should be fine. They were never removed. So yeah, let's go ahead and move on. So the next step here is a flush of the system. As we've repasted both the CPU and GPU, we know we're good there. Now we just want to get all those particulates out of that old coolant that may be settled in things like the radiator or in the blocks themselves, just to make sure that's all cleared up. How we're going to do that is I'm going to take a gallon of distilled water and basically run it through the system. I'm going to fill it using this little fill bottle, which we can fill up front. Then basically, because I don't want to have the entire system on while I'm doing that process, I have a spare power supply hooked up with a jumper and to the actual pump itself. So that just is the only thing that's going to be turning on. That will turn on, the pump will run. That will allow us to go ahead and fill the loop up, let it run for a little bit, make sure there's no leaks or anything, make any corrections we need, and then we'll go ahead and fill it up and basically make sure that it's clear coming out. As long as it's clear, we're good. If not, we might have to go ahead and do another flush just to clear things up a little more. So that's it, so let's get started. All right, so what we're doing here now is we're gonna go ahead and fill this reservoir. We're going to take our thing right there and just let it fill up that front reservoir. It's going to take a little while just because there is a good amount of fluid that has to go in here. Now that we got the fluid level all the way up to the top, the next step, because we have the power supply jumpered, is just basically to turn it on and let the fluid run. This should run the pump. We should see the fluid start moving. Move some of the air bubbles out. We're going to turn it off, cycle it. And we'll see that the fluid level is coming down. We're going to fill it up again, add some more liquid. So that should be enough for the system to run completely independent on its own. I shouldn't have to shut it off this time. Turn that power supply on. We can see the pump should start. Water's flowing. We're just trying to get any of that extra gunk out right now. Also make sure there's no leaks. So I've had the system running for about 10 minutes now since I first turned it on with this fluid. Basically it's just distilled water that we got in there. And yeah, there's no leaks. Everything looks good. I noticed that the flow rate seems to be better up front, which is a great sign. It means that we're actually getting some better movement of that liquid. Hopefully whatever was gunked up in the radiators or blocks is going to be cleared out by this distilled water. We're going to let this run maybe another couple minutes, and then we're going to go and drain the entire loop and fill it up with some brand new coolant, and the system should be good. We'll test it, and yeah, we'll go from there. So everything's run pretty good now. Let's go ahead and drain this system, and let's fill it up with some new fluid. To drain it just like last time, what I'm going to do is I'm going to hold the bucket underneath it. I'm going to move it all the way kind of to the edge of my desk. We're going to go ahead and just hold the bucket underneath, release the actual fitting on the bottom, and we should have the fluid come right out. There we go. And look at all the residue in there. Wow, that is not good. We might have to do one more flush, it looks like. That is not what you want to see. You don't want to see all that white residue, whatever particulates those are left over from probably the last liquid that was in there. That is not a good sign. So we're going to go ahead. I mean, the water looks pretty clear. It's definitely a little cloudy, but let's finish pulling the rest of the liquid out of here. So this is the stuff we don't want to see. You see this white little residue that's being left behind? It could be just some kind of like bubbles, but typically anything like that, you can see the stuff down at the bottom too. That is typically something that's fallen out of the previous liquid. And you can see it in the tubing as well. There's a little bit of it throughout the entire bit of tubing. So we're going to go ahead and do one more flush, do some new liquid, and we should be good there. All right, so I refilled the system again, let it sit. Everything seems to be a lot more clear. Flow rate's even better. This time we're going to go ahead and drain it and actually fill it with some good fluid. So we can do that same way that we just did the last one. Something I did think about is we could just use the screwdriver as a way to kind of funnel the liquid down. This should help. So all we got to do is just leave the screwdriver there. And hopefully keep that liquid just going down it instead of going off to the side. There we go. Let it flow down. And yeah, that cleaned up pretty good. Looks a lot better inside. There's just some bubbles, but there's not the same residue that we saw before, which is what I was really looking for. Not too bad of a way to like drain and fill the loop, but it's definitely not ideal, I'll tell you that. They definitely could have made it a lot easier. Something like a ball valve on the bottom would have been absolutely worth it to go ahead and keep that pressure, so you could put something on like a fitting with a piece of tubing, which is my preferred way when I do any type of custom water-cooled builds. But yeah, so the thing's nice and emptied. We're going to tilt it, make sure we got everything out. Perfect. So I looked around the office. I had a brand new bottle of Corsair Hydro X, their coolant. This is a clear coolant. It's going to be good. This stuff's pretty clean, so it should be a pretty good fit for this system. So we'll go ahead and throw this in there, and let's get it filled. All right, so after draining the loop one last time to fill it up with that Corsair fluid. So we're going to go ahead and fill this loop up. All right, now let's fill it. Let that run. Get all the bubbles out. So after letting the brand new coolant run in the system, I've had it up for about maybe an hour on the external power supply. Everything looks good. I've been able to get all the little air bubbles that were trapped inside out, and you know, everything looks good. I've got no leaks, meaning we can start pulling off all the paper towels. The only thing that was leaking was just my mistakes with filling it up. But yeah, as far as the actual system, everything looks good there. So now all we got to do is connect the old power supply back up, put the system back together, and test it. So one of the first things we need to do is put that front panel back on to the case. So I'm going to wipe this off because it is pretty dirty. All right, so that looks a lot better. Now all we got to do is just snap it on up front, like that. And yeah, we got the front back on. And now let's go ahead and close the case up and test it. So with everything put back together, let's go ahead and do our first live boot of the system. We should be good. Everything checked out beforehand. Now we're just running the pump off of the internal power supply and turning everything on. And it looks pretty good so far. We got movement of our fluid. We got display. That's always a good sign. So let's go ahead and load up our test. We're going to load AIDA64 up as well as Furmark. Go ahead and do some comparisons to before and after and see if we got those temperatures drop down to a reasonable level. It should be definitely a lot better. I know the flow rate is definitely higher now, as well as, you know, that new thermal paste always helps out. So after about 10 minutes of putting this system now under a full load stress test, after doing all the work that we did to it, we've got some really impressive results. Because I have both Furmark running, this is Furmark 2, and AIDA64 running. That's pushing about 450 watts worth of thermal dissipation into this loop, and it's handling it quite well. Because right now, our GPU is sitting right around 52 to 53 degrees Celsius with a hot spot at 64 degrees Celsius. That's over 10 degrees cooler than it was beforehand, and it gets even better. When we look at our CPU temperatures, we saw one peak at 90 degrees Celsius, but we're sitting about 83 degrees right now. That is a really solid point to be at, especially for a system like this with a 10900KF. That CPU did run warm, and with all that running on the system, yeah, those are great temperatures. And instead of going to 100 degrees Celsius, making the system thermal throttle down to like 3.2 to 3.5 gigahertz, we're now back at 5 gigahertz like the system is supposed to run at. So yeah, we are good here, and the system is not going to be unstable for our customer anymore. We don't have to worry about the system crashing because of it getting too hot and not being able to thermal throttle. So let's go ahead and get it back over to our customer. But before we do that, make sure you guys give this video a like, subscribe for more content like this, and take a look at this video here if you enjoyed this vlog style content where I went ahead and did a full rig rebuild for a customer of ours for completely free. It was a really cool video, and I'll see you guys in the next one.